All right, good morning. Welcome to Activity for Processing 2.13, which will get you ready for Cool Down 2.13. As a reminder, these videos should always be accompanied with your lovely notebook, where I always welcome you to not only take notes, but flood the board, ladies and gentlemen, with annotations, notes, and any other thoughts that you feel will be necessary for you to, when you look back at your notes during a midterm, during your final, or anywhere, if you keep your notebook for later years, to look back and be like, what was I talking about right here? So those annotations, those notes are a great way to make sense of it when you go back, right? All right, without further ado, let's begin. So Activity for Processing 2.13 is an extension lesson of lesson 2.12. And as a reminder, in lesson 2.12, we were doing division with a box. Here we're going to do polynomial long division with, for 2.13, I'll label it here. We're going to use the old school division symbol, like 6 divided by 3, which is 2. That's polynomial long division. So that's for today. This is what we did last time. Now, in order to tackle this lesson, we're going to have to add a new wrinkle, a new layer here of information. But we've seen this in Algebra 1, and this is called factoring. So these three examples, I didn't know what else to label them. These are not your real examples 1, 2, and 3. Rather, these are your examples 1, 2, and 3 for review on factoring. So if you see me labeling these, and then I do the practice problems here on the whiteboard and label it example 1 again, it's because these are not the lesson. These are, once again, I'm going to say review. Well, let's begin. So in order to factor x squared plus 6x plus 9, I like to organize my work. And I like to annotate the number 9 and the number 6. I put a multiplication sign above the 9 and a plus symbol above the 6. What these symbols mean is that I need two factors of 9 that multiply and give me a product of 9. And those same factors also need to give me a sum of 6. Allow me to demonstrate. One example is 9 and 1. 9 times 1 is 9. Beautiful, I love it. Now let me add them. 9 plus 1 is 10. Not what I wanted. Try again. Okay, I need to think to myself of two other factors of 9. Let me try 3 and 3. Okay, 3 times 3 is 9. Beautiful. 3 plus 3 is 6. That works. I'm going to put my factors 3 and 3 here. And notice I did put a positive sign because by default, when you don't have the signs in front, it's positive. However, let's move on to example 2 where we will get a taste of negatives, right? So now I need to think once again. I need a product of 9 with two factors of 9. And those two factors of 9 need to give me a sum of negative 6 this time. So I'm going to try those numbers. 9 and 1 give me 9. 9 plus 1 is 10. Not what I wanted. 3 times 3 is 9. 3 plus 3 is 6. Negative 6, not what I wanted. So now I'm going to have to try these out. Negative 3 times negative 3 is positive 9. That works. Negative 3 plus negative 3 is negative 6. That works. Okay, cool. And then this last one's a bit tricky. So you got x squared minus 25. So what I'm actually going to do here, and I didn't write the problem like this, is I'm going to add a middle term to make it look similar to the other ones. I'm going to put plus 0x. Okay. So now I need to get two factors that give me negative 25 and a sum of 0x. So the two factors should be negative 5 and positive 5. Negative 5 times positive 5 is negative 25. Negative 5 plus 5 is 0. And what helps me sometimes is when I get into this box here, is just add it mentally real quick. Okay, negative 5 times 5 is negative 25. Bingo. Negative 5 plus 5 is 0. All right, thank you folks for allowing me to take a moment to review on factoring. Now we can hop into our actual examples for polynomial long division, now that we know this here. And as always, I'd like to remind you, if you see an example and you're like, hey, let me try it, myself, always pause the video and try the problem out for yourself. Okay, so this is our quote unquote example one for the lesson. Now that we're done with review on factoring. So what we're gonna do here is we need to set up the problem like this. Okay, so you see, this is kind of the same as the box that we did last lesson, but now we have like this division symbol. We're not dividing by a number anymore, we're dividing by binomial. So the same idea applies, right? Okay, so here's how this works. The main focus here is with this variable in the binomial, and you want to make it such that whatever I'm going to place up here, I'm going to put a little question mark, an unknown value, x times something gives me x cubed. So what I'm going to put there is x squared. X squared times x is x cubed. And then we're going to multiply, since we already multiplied it by x, now we're going to multiply it by -7. So we multiply this value times both terms of this binomial here. So x squared times x is x cubed. X squared times -7 is -7x squared. Now, this next step, different people do it different ways. Well, we all do it the same, but we each show it differently. So this is how I like to do it. And by all means, if you find a better way, I will respect it. However, there's a reason why I do this, which will make sense later. So whatever you get as a product of the distribution between x squared times these two terms, you put in here, and I like to put them in parentheses with a subtraction symbol. What other people like to do is they like to switch the signs. I don't like switching the signs, and the reason is simple. Because if I switch the signs and I make a mistake, I go back, I don't know what I did. But by doing this, I'm not changing anything. I can go back and say, okay, I subtracted. If what I'm saying right now doesn't make sense, try both ways. Try switching the signs, and then if you make a mistake, if that works for you, being able to go back and track your work, that's fine. But that doesn't work for me. Okay, so this subtraction symbol means we're going to subtract the contents inside the parentheses with whatever is above. So I'm going to line up here the values with this little arrow here and here. And then I have to tell myself x cubed minus x cubed. Well, that's 0x cubed, so that's canceled out. But I'll write it out. But there you go, just canceled out. So you don't even have to write it right there. But I for the reason of teaching, I'd like to show you that, right? Okay, now two negatives make a positive 7x squared. Positive 7x squared and negative 7x squared will also cancel each other out. So there it is, it's gone. So now that we've done that first step, okay, now you bring down the next term. I'll bring it down right here. So now be careful, because that next term is not 16x, it is negative 16x. So when you bring down a value, make sure you bring its sign with it. Okay, so now we got x, you have to match it up with negative 16. So x times negative 16 gives you negative 16x, and then 16 times 7 gives me two negatives, give me a positive 112. Okay. Now I am going to bring down this 112 here, put this minus sign, and then just tell myself, okay, these two are going to cancel out, and these two are going to cancel out. And my remainder is 0. Once I get my remainder to be 0, excellent, I'm done. However, the problem's going to ask you to write the answer as a product of 3 linear factors, very similar to the last one. So this is what we have so far. We have broken up the original polynomial into a product of a linear factor and a quadratic factor. So you should see this right now. Why did we do a review on factoring. This is where it comes into play. So if it helps, I'm actually going to rewrite that problem with a middle term, turn it into a trinomial. This step is additional, it's not needed. However, it helps me show what it is I'm trying to like talk about here. So in order to factor this, I need two values that will give me a product of -16 and a sum of 0. So I got x minus 7. And now I'm going to break this up, and let me put it in red parentheses so I can show my audience where are the two linear factors coming from. They're coming from the trinomial up here, this quadratic trinomial. Okay, so now I got x, I need two factors that give me -16. Positive 4 times -4 is -16. Good. Positive 4 plus -4 gives me 0. Great, that works. Here is our product of three linear factors that if we multiply these three right here, will give me back my original polynomial, ladies and gentlemen. All right, thank you for checking out example 1. Till then.